Today we're going to talk about trigonometry and application trigonometry in the word problems. So we will start with one of the most common problem about the Ferris wheel, even though you might not have exact the data I do have for this problem, but the general idea of solving the problem is common most of the times.
Suppose that after you are loaded into a Ferris wheel car, the wheel will begins turning at 4 revolutions per minute. The wheel has diameter 12 meters and the bottom seat of the wheel is 1 meter above the ground. Express the height h of the seat above the ground as a function of time t seconds after it begins turning.
Let's make a little sketch, a little diagram of the Ferris wheel. I'll do my best here. Alright, so say here our Ferris wheel. Not that round, but it's okay. Okay, the center, so here's the cart. Alright, and let's put the data we already know. It's given to us, so we know that the Ferris wheel is located 1 meter above the ground, so that little distance will be 1 meter. We know that the diameter is 12 meters, so that makes my radius is 6 meters. We need to actually, so what they ask to write an equation, trig equation, to express height versus time in seconds. So in order to do so, let's remember what's the general form function with all the transformations for sine or cosine. So here we have fx equals a sine 2 pi over px minus pn plus w, and that would be exact the same thing for our cosine, cos 2 pi over p minus x minus pn plus w. So where a represent amplitude, 2 pi p here is period. This is our horizontal shift, right or left, it depends on the sign, and our real axis, or also midline, W. So how to find it, maybe some of you already know, probably, but just to remind you that amplitude is maximum value minus minimum value divided by 2. The middle line, it's a midpoint for your maximum and minimum value, which is max plus minimum divided by 2. The shift, it also depends on their sketch in the graph, so you can actually see it there. And P is the period. Alright, so we can start actually from sketching the graph. So let's do that. We need to define what's our period. So what do we know about it? We do know that the Ferris wheel, revolutions per minute. We know that the Ferris wheel does 4 revolutions per minute, so 4 full turns in 1 minute. So 1 turn, it's 1 period, right? So how many seconds we need to have in order to complete the full rotation? So if we do 4 in a minute, so 1 minute, it's 60 seconds. So if we do 60 seconds, we divide by 4 because we do 4 full rotation, it gives us 15 seconds. So in 15 seconds, Ferris wheel does the full rotation. So let's say this is our time in seconds. This is our height in meters. Now, let's find our maximum value. So height max. So since this is 12 meters diameter and the minimum point will be here, 1 meter above the ground, so the maximum height will be 13 meters, or 1 plus 12, right? Now, in order to find minimum, we know that minimum will be at that point, and that would be 1 meter. So now, excuse me, let's find the amplitude. As I said, the amplitude, it's maximum minus minimum divided by 2. Which is 6 meters. The amplitude is 6 meters. Now, okay, we know this. We can easily find our real axis or midline. It's a midpoint, so it's 13 plus 1 divided by 2, so it's 7 meters. So, okay, we can actually put here some data we already found. So minimum is 1 meter, so maximum is 13, and the midline is 7. So that would be our midline. Just to help ourselves, we can put the dotted lines here as well to show that within this range, we will have our graph. All right. Now, let's go back to the Ferris wheel. So what do we need to find? We need to express height versus time in seconds. So what's happening with the height? We start at the minimum point. We go up, 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 up. We increase in our height. We keep increasing our height. In the middle of the way, we achieve our maximum value, and after that, we're going slowly down back to the minimum point. So, we know that the full rotation occurs in 15 seconds. So that's our period. Our period is 15 seconds. So that would be 30, that would be 45, and that would be 60. All right. So we know that in the middle, halfway through, it does reach maximum point. So maximum is 13. It starts with minimum point and will go back to the minimum point to complete the rotation. So in the middle of between those 7.5 seconds and from 7.5 to 15, it will go to 7. All right, so now we are ready to graph. Okay, sorry, not too perfect, but you get an idea. So that's our full period. We can keep going and just finish this one up, just a sketch. Okay, you know, it's not exactly great, but it's okay, you get it. All right, so we did 4 rotations per minute. So we can focus on just only one in one period of time for one revolution. And just now we need to decide whether it's sine or cosine, right? How does it look like? Does it look like sine or does it look like cosine? So what do we know? If we do a little sketch here, just to remember, the period of sine actually have to start like this, right? It goes one loop above the midline, one loop below the midline. For the cosine, it's for sine. For the cosine, we go from max to max, right? In this case, our period basically from one minimum to another minimum, from minimum to minimum. So it's definitely not sine. It doesn't look like sine. But our cos is from maximum to maximum, but negative cos actually goes from minimum to minimum. So that tells me that that would be negative cos. All right, so we did a sketch. Now we need to make an equation just to take into consideration any transformation that cosine function might have. All right, so we already identified that it has reflection across x-axis. Now, let's go again. Let's go back to the common version of function, of trig function with the transformation included. So since we know it's cosine, we found the amplitude. The amplitude is 6, and we know it has a reflection across x-axis, so it will be negative 6. So let's put that our height of versus time in seconds, height in meters, will be negative 6. So it's our amplitude. We already know that it will be cos. Now, 2 pi about the period. So the period, we already find that the full rotation will occur in 15 seconds. So that will be over 15. Now, t minus. So is there any horizontal shift? Our minimum starts at the 0 axis. So there is no horizontal shift. So that means we have only 2 pi over 15t, okay? Now, so we just need to write the real axis on midline, and that's 7. We already find plus 7. That's it. That's an equation. So we have negative 6 cosine 25 over 15t plus 7. Amplitude, period, midline, and there is no shift. So that's how you solve the problem. Thank you guys. If you have any questions, please comment below and let me know. I will address all your questions. Good luck. Thanks.